All right, so today we're going to look at what's called combining like terms. And you'll see these first directions say write an equivalent expression to demonstrate the relationship between multiplying and adding. Let's first start off. Does anybody know what this word equivalent means? Because this whole unit is about equivalent expressions and we need to know what that means. Carlina? It means the same, or another thing is just kind of like equal, right? Expression, I looked it up in the dictionary, and it said numbers, symbols, and operations grouped together to show the value. So what that essentially is saying, like an example of an expression would be something like 4x plus 3. That's an expression. It's, we have an operation and we have numbers put together and it's ultimately going to have a value. Expressions, you won't see that equal sign. Yes, you can work them out and figure it out, but you won't see that equal sign. So that's an example of an expression. Or another expression would be, this 6 plus 6. That's an expression. It's numbers and symbols, operations grouped together that has a value. That's what an expression is. Okay, so when you hear that term, that's what we're talking about. Now this says write an equivalent expression to demonstrate the relationship between adding and multiplying. So I don't want to put 12. That's not what we want. We want something that it's equal to. That's another expression. Anybody have a thought? Brody? You are right. It would equal that. You are totally right. It would equal 3 plus 3 plus 3 plus 3 plus 3. That would be an equivalent expression. And for the sake of this, I'm not going to put it down because this is purposely leading us into something else. So this problem, the addition, can relate it to a multiplication expression that would be equal to this, is what I'm, getting at. Chris? I could do 6 times 2. Sure. Or I could even do 2 times 6. What about this one under B? Cameron? That would be C, right? So yeah, you said, okay, so that one is 4 times 5 because I have 1, 2, 3, 4, 5 4s added together. So if we're talking about B, 1, 2, 3, 4, 5, 6 3s added together. So that's 6 times 3, or you could say 3 times 6. So, right, we kind of get the hang of that. This is a review on purpose. Looking at this D, now we have multiplication. Could you give me an addition expression that would be equal to this? Leo?
6 plus 6.
I could do 6 plus 6. What else could we do? Jada? 1, 2, 3, 4, 5, 6, right? All added together. Nice job. So either one of these would be equal to that. Different ways of writing the exact same thing. I don't think we need to do all of these on this page, but I did want to. The purpose of doing this other stuff is for these two right here. Okay, this is the beginning of what's called combining like terms. So when you see this word terms, it's referring to the parts of an expression. So terms are the parts of expression. So like in this E, 4 is a term and 6 is a term. All right, in C, this is a term, this is a term, this is a term, this is a term, this is a term. Right? So all the 4s in here are different, what you'd say, terms. Just a vocabulary word that you need to know what it means. Question? What do you think G is?
H times 5 or 5 times 8.
Okay, so the correct way, they're equal to each other, you're right. I could say H times 5 or I could say 5 times H. But how you're typically going to see it is with the number first and then the letter. Okay? So 1, 2, 3, 4, 5 H's. And we know 5H is also equal to 5 times H. Now, as you progress in algebra, you're going to see this multiplication symbol in between here less and less. It's more so going to be like this, and that when you see 5H, it means there's 5 H's added together or 5 times H.
H, you have to do like if you do an addition, you have to do a started multiplication. You have to do like 5 times 5 times 5 times 5 times 5.
Okay, so we're going to get there in a minute. So this, another vocabulary word, again, I know we're looking at a lot of vocabulary words, but the 5 is called the number before the variable, how many of the variable I have is called the coefficient. Coefficient. And again, it's another word that we need to know. I get it, I'm giving you a lot of vocabulary words today, but we need to know this. So this 5 is called the coefficient. It's telling me how many of the H's that I have. 6y, what could that be? Lexi? 4, 5. So then my question to you, I agree with you, right? This is related. How is this different than that? How are those different? How is 6y different than y to the 6th? Tina? So the exponents are all about repeated multiplication. And this multiplication is repeated addition. So they are not the same thing, and we need to recognize the difference in that. Questions so far? This 6 here in front of the y is called the what? Connor? Coefficient. All right, coefficient. All right, let's go to the next page. All right, looking at this, this says x plus 6g minus 6g is equal to x. Take a second, I'm going to say like 15 seconds, and just discuss it with your table. What do you think? Is that true? Is that false? I get it, it's something that maybe you haven't seen before, but try and relate it to stuff that you know. Just like we did with the last one, relate it to things that you know. All right, so let's have a conversation, right? I wanted to relate it to something that you guys maybe know, like we did on the last one. So if I started off with 2, and then I add 4, where am I at? 6. Then I subtract 4. Where am I at? 2. So when I add 4 and then I subtract 4, that ultimately is going to be like kind of canceling each other out or making 0, right? So 2, this is essentially saying 2 equals 2. When I'm looking here, I don't know what 6g is, but if I add it, and then I subtract the exact same thing again, that's kind of like it just cancel each other out. So x equals x, so this works. What about with b? Adam, what do you think? Why? Why do you think it's true?
At the beginning it says 2f and you're subtracting 4e. But then you add 4e again, which then will just cancel out.
So if I subtract something and then I add the exact same thing back, it gets me to where I started. So 2f equals 2f. Awesome. Now we're going to take a step up, combining multiple terms. So again, we're looking at relationship between addition and multiplication. What do we think this first one would be? Melissa, what do you think? For A right here, what could that be as a multiplication problem? Six times 4 plus 4 times 3. No. And you could work it out, right? And it's not asking us for it because it just says write an equivalent expression, and 36 wouldn't be an expression. I could put them in parentheses if I wanted to. I don't have to because multiplication comes before addition. With this, same exact kind of thing as this. Same exact kind of thing. So when I'm thinking about variables, I can't let my brain get freaked out about it. I need to just think of it as numbers and we'll be good. Leo, you have a thought?
Just after we do the next one.
Yeah.
Okay. D times 3, or 3 times D,
Okay.
and 5 times W.
And what am I going to have to do with those?
Oh, parentheses.
I need to make sure I have the addition sign down. So you'll notice a couple things here. All right? You'll notice that I didn't add everything together. It's called combining like terms because you can only add or combine the stuff that is the same. So D plus D plus D. Only the D's can be added together. The W's can be added together because we don't know what the value is. And a D and W will have different values. So if they have a different variable, means a different value. And we know, in this case, 3 times D plus 5 times W, we know that multiplication is before addition, so I'd have to multiply them out before I could ever add them together. All right, I'd have to, multiply it out before I could add them together. Last little pointer on this, they should go in ABC order. So D comes before W, so I put D first here. D before W because it's ABC order. And this 5 is called the what? Leo?
Coefficient.
Coefficient. All right, C. Taking a look at C. Lexi?
2 times A plus 3 times B plus 4 times C.
And again, the further you go in algebra, the less you're going to see those multiplication signs. So this means that 2A plus 3B plus 4C means 2 times A plus 3 times B plus 4 times C. But you're going to see it less and less and less and less. Yes, ma'am. Questions with any of this right now? Okay. On the next page, I'm going to have you guys try these, and I'm going to put a timer. 4, 5, and 6 is what I want you to do. I'm going to put a timer for 30 seconds because I don't think it should take you longer than that, and I want to show you one other thing to get on the video. All right, 3 times 9. Tina? 9 plus 9 plus 9. What else might we have, Gabe?
6 plus 3 plus 4 plus 6.
Okay, I could have done it like that. Yeah, I didn't think of it like that. That would work. That would work. I could also say this is 3 plus 3 plus 3 plus 3, 4, 5, 6, 7, 8, 9. Right, so I could have done it like that. Now this 6m, Casey?
6. I mean, m times m times m times m times m.
So she said 6m equals m times m times m times m, 4, 5, 6. Connor?
Instead of multiplication, it's addition because it's 6 times m.
Okay.
An exponent.
So this here, right, a new symbol for you guys, this is an equal sign, and if there's a line through it, it means not equal, just like if there was like a cigarette and you had a line through it, it would mean no smoking. This means not equal. So these two are not equal to each other. And Casey, what you were thinking of, I think, is what Connor just said. That would be m to the 6th power because it's repeatedly multiplied. So 6m would be m plus m plus m plus m plus m plus m. 1, 2, 3, 4, 5, 6. And then the last one here. Nina, could you help me out with this one? D plus D plus D plus D plus D. Or I could just write 5D. Very good. Last thing I want to talk to you guys about, okay? So we saw how it works with adding and multiplying, how they're related.
Yeah.
How do you think it would work if I did something like... How do you think like that would work? Chris?
Yeah, to find out the value of x first.
That would help us get a final thing, you're right. But there's a way I could kind of like simplify this or combine like terms there. Yeah.
5 times x.
Well, this is 5 times x. You're right. Adam?
X plus x.
Okay, so I could think of it like that. This is x plus 2, 3, 4, 5. And then this part of it is x plus x. So ultimately, what's it going to be? Jada?
Well, first you can add 5 and 2, and then have it so it would be 7
So this is 7x. This is combining like terms. It's adding together. The terms are the same. How the terms are the same? Because they're both x's. Because if I wrote them out in like expanded form like this, there's 1, 2, 3, 4, 5, 6, 7 of them added together. So 7x would be what that is. Last question, okay? So we know that. What if I said 3x plus 2x minus x? Well, let's think of, before we do this, let's think of 3x in expanded form. Would be, Caleb, 3x in expanded form?
3 times 3 times
No? Keelan? No? Okay. So that's x plus x plus x. And then 2x in expanded form. Brody? X plus x. And then subtracting an x would be like just crossing one out. So it would ultimately equal 4x. 3x plus 2x makes 5x. Minus x would be 4x. Now I want to show you the most common mistake, and then I promise we'll be done, okay? A lot of people, when they look at it, they say 5x minus x, and they want to say, oh, that must just be 5 because the x's must cancel each other out, right? Like if I have 5x and I subtract an x, they're thinking it's just 5. And that's not correct. Because this part did equal 5x, and you can see it from here, but subtracting an x is taking 1x out of the equation, so that leaves me with 1, 2, 3, 4 x's.